let's take a look at some fundamental integrals. Number one, the integral of x to the n dx is 1 over n plus 1 x to the n plus 1 plus c. Number two, and incidentally, for number one, remember n cannot equal negative 1. Now, the natural thing is, well, what if n is negative 1? Then we're looking at the integral of 1 over x dx. And the integral of 1 over x dx is natural log of the absolute value of x plus c. Number three, the integral of e to the x dx is equal to e to the x plus c. Number four, the integral of a to the x dx is equal to a to the x divided by the natural log of a plus c. Okay, now remember here, a is greater than 0, and then a doesn't equal 1. Now, for example, suppose I had the integral of 2 to the x dx. Well, in this problem, a is 2. And so we get 2 to the x divided by natural log of 2 plus c. Okay? Number 5. The integral of sine of x dx is negative cosine x plus c. Number 6, the integral of cosine x dx is equal to sine of x plus c. Number 7, the integral of tangent x dx equals. Now, let's suppose we don't remember the integral of tangent x dx. If you know the integral of sine x dx and the integral of cosine x dx, just like with derivatives, you can get the integral of tangent x dx. Why? Because you can write this as the integral of sine x divided by cosine x dx. And then we can do a quick u substitution. So u is cosine x, du is negative sine of x dx. So negative du is equal to sine of x dx. And so from here, the integral of sine of x over cosine of x dx can be written as negative the integral of 1 over u du, which is negative natural log of the absolute value of u plus c. But u is cosine x, so this is negative natural log of the absolute value of cosine x plus c. So therefore, putting it together, the integral of tangent x dx is negative natural log of the absolute value of cosine x plus c. And that was number 7. So let's take a look at number 8. The integral of cotangent x dx. Okay. Now, we can reason it in much the same way. This is the integral of cosine x over sine of x dx. And I'm going to let u be sine of x. Du is cosine x dx, right? And so, therefore, the integral of cosine x over sine of x dx is the integral of 1 over u du, which is natural log of the absolute value of u plus c, but u is sine of x. Okay? And we're done. So we can say the integral of cotangent x dx is natural log of the absolute value of sine of x plus c. Number 9. Suppose I have the integral of secant x dx. And this is another one I want to expose you guys to because we might have forgotten or what have you. Now, what I'm going to do is I'm going to multiply the numerator and denominator by secant x plus tangent x. It's like multiplying by 1. We can do that. Okay. Now, distribute the secant x inside. And when I do, I get secant squared x plus secant x tangent x divided by secant x plus tangent x. And I want you to observe that the derivative of secant x is secant x tangent x. The derivative of tangent x is secant squared x. So it's a perfect setup for u substitution. So I'm going to let u equal secant x plus tangent x. du is secant x tangent x plus secant squared x dx. So the integral of secant squared x plus secant x tangent x divided by secant x plus tangent x dx is the integral of 1 over u du, which is natural log of the absolute value of u plus c, but u is secant x plus tangent x. So this is natural log of the absolute value of secant x plus tangent x plus c. Okay? Therefore, the integral of secant x dx is natural log of the absolute value of secant x plus tangent x plus c. Number 10. Suppose I have the integral of cosecant x dx. So I'm going to do something very, very, very similar. So I'm going to multiply the numerator and denominator by cosecant x plus cotangent x. So this is what I have. Okay, nothing illegal because I multiplied numerator and denominator by 1. So this is the integral of cosecant x squared, right? Or cosecant squared x plus cosecant x cotangent x divided by cosecant x plus cotangent x dx. Now, I'm going to let u equal cosecant x plus cotangent x du is negative cosecant x cotangent x minus cosecant squared x dx. And so I'm going to factor out that negative. And then when I do, I get the opposite, or the negative of cosecant x cotangent x plus cosecant squared x dx. And so negative du is cosecant x cotangent x plus cosecant squared x dx. Now, let's see if we can put everything together. The integral of cosecant squared x plus cosecant x cotangent x divided by cosecant x plus cotangent x dx. This is negative the integral of 1 over u du. But this is negative natural log of the absolute value of cosecant x plus cotangent x plus c. And I'm done. Therefore, the integral of cosecant x dx is negative natural log of the absolute value of cosecant x plus cotangent x plus c. And that'll conclude this video, and we went over a list of fundamental integrals. And I will make another video where I will give you more fundamental integrals. Okay, thank you.